Hello, everyone. Good morning, good afternoon, and good evening. Welcome to Trimble Tech Tips. I am Dhiman Deb Chaudhary. Today, I will be discussing GNSS timing, what it is, and how it is obtained by networking gears to provide time synchronization for the network. So, GNSS or Global Navigation Satellite System is a constellation of satellites that are placed in the MEO or medium Earth orbit. Different types of satellites, including GNSS satellite constellations, are placed in the main three orbits. The first orbit is LEO or low Earth orbit. The second is medium Earth orbit or MEO, and third is GEO or geosynchronous Earth orbit. LEO satellites are placed within LEO, which starts at 160 kilometers from Earth's surface and extend up to 2000 kilometers. MEO satellites are placed within MEO, which starts at 10,000 kilometers and extend up to 20,000 kilometers. And GEO satellites are placed within GEO or GSO orbit, which starts at 36,000 kilometers. LEO satellites provide communication and military service, whereas MEO satellites are GNSS satellites that provide PNT, positioning, navigation, and timing services. GEO satellites are geostationary satellites that provide weather and oceanography services. GNSS constellations include six main group of satellites that are GPS, GLONASS, Galileo, Baidu, Navic, and QGS. GPS is sponsored by US, has 32 satellites in the orbit, out of which 31 is operational. GLONASS is sponsored by Russia, has 28 satellites in the orbit, out of which 23 is operational. Galileo is sponsored by Europe, has 30 satellites in the orbit, out of which 24 is operational. Baidu is sponsored by China, has 49 satellites in the orbit, out of which 44 is operational. Navic is sponsored by India, has 8 satellites in the orbit, out of which 7 is operational. And QZSS is sponsored by Japan, has 4 satellites in the orbit, out of which 4 is operational. GNSS system can be divided into 3 parts. The first one is space segment, comprises of satellite constellation. Second is ground or control segment, comprises of master stations and control stations. And the third is user segment, that comprises GNSS receivers that are implemented in various different devices in different industry verticals. Every GNSS satellite carries an atomic clock on board to provide reference clock to various different subsystems within the satellite. Atomic clock is considered international standard to provide primary time reference for unit of time. GNSS satellite carries different types of atomic clock. For example, GPS carries rubidium and cesium, GLONASS carries cesium, Galileo carries hydrogen mixture and rubidium, Baidu carries rubidium, Navic carries rubidium, and QZSS carries rubidium. GNSS or GPS system time is obtained through synchronization between monitoring station and onboard atomic clock of a satellite. Through this process, SB time or space vehicle time is obtained. This SB time is further synchronized with UTC and carried over SV nav messages to the GNSS receiver. GNSS receiver correct that information and provide primary reference clock to the network devices or any other devices requiring primary reference time. Trimble offers a range of products for user segment, from custom GNSS receiver to timing module. Timing module can be implemented within a GNSS receiver, or any other systems requiring GNSS receiver functionalities. For example, it could be implemented within a base station of 5G networks to provide GNSS receiver functionality for primary reference time. Trimble's industry-leading timing modules includes RES 720, RES 360, and ICM 360. RES 720 provides both L1 and L5 with a 5 nanosecond accuracy, whereas RES 360 and ICM 360 provides 15 nanoseconds timing accuracy. Interested in learning more? Please visit us timing.trimble.com. Thank you for watching this video presentation. Please do not forget to subscribe us and also visit timing.trimble.com.